Hi, folks. Welcome back. I hope you're all doing well. So, continuing with the theme of the impact of large language models on teaching computer science, I want to take a look at this paper where the authors have gone out and interviewed a bunch of CS Intro to Programming instructors from various universities all around the world and asked them, well, how are you going to adapt your curriculum or your teaching methods given all these AI tools like Copilot and ChatGPT that are now fairly accessible to students everywhere? And this was really timely because it was done just around the time that the first full starting fall semester would happen since the initial release of ChatGPT and when this whole thing blew up. But first, just to set the background, what can all these AI coding tools do? There's a very common misconception that they are essentially autocomplete on steroids, and that doesn't even begin to cover it. And the authors here have a long laundry list of all the things AI tools like Copilot can do. Obviously, the most basic one is that given a natural language description, they can emit code to do that. But going further, if you don't know what your spec is, you can actually have a conversation with the LLM. It can ask you clarifying questions to arrive at a precise spec. You can refactor code. You can ask it to simplify code. You can ask it to translate code from one programming language into another. Given a piece of code, you can ask it to generate tests for that code. You can even ask it to generate synthetic test data for your tests. And going beyond just writing code, you can ask it to explain pieces of code. You can ask it about bugs or test failures in your code. And in general, you can use it as a code review buddy that's always looking over your shoulder and giving you helpful suggestions. So really, they can do a lot more than just autocomplete and can help students with the entire cycle of writing code, writing tests, explaining code, debugging code, and so on. But of course, we know it's not absolutely perfect. These tools do have limitations. The most important limitation is that they can hallucinate. They can generate code that is buggy or incorrect. The other big problem is that the large models have a cutoff date of the knowledge they were trained on. So stuff that is newer than that cutoff date is not going to be in that world knowledge. You can mitigate this somewhat with retrieval augmented generation, though. The meat of this paper is the authors doing free-form interviews with 20 introductory programming instructors from all over the world and asking them about how they're dealing with this, how they're changing their curriculum or their teaching practices. As you can see in this table, some of them had used ChatGPT or Copilot to various degrees. Some of them had not used them at all. So they have a pretty diverse sample. The high-level summary of what they found was most instructors in the short term are very concerned about these tools, mainly because of cheating concerns. But in the longer term, they split into two large camps. One camp wants to resist the use of these AI tools, and another camp wants to fully embrace these tools and then see how they can shape the use of these tools or change the way they're teaching or change what they're teaching. So let's look at these responses in a bit more detail. In the short term, like I said, everyone was concerned about cheating. The authors note that all 20 participants brought up cheating even though they were not asked about it. So this was on the top of their mind. Obviously, the big concern there is that students could just generate answers to programming assignments without actually understanding or learning anything. So given that concern, a lot of instructors have made some short-term changes to the way they're teaching these courses. A few common measures were to weigh exam scores more heavily compared to programming assignments. One drastic measure was to ban AI tools completely, but then they also acknowledged it's not really enforceable. Another approach was to actually tell students about both the capabilities as well as the limitations of these tools. They all commented on how these short-term measures were really patches. They were not perfect, but it's the best they could do right now because they have to teach this course today and they don't have the time to completely revamp it or to think through how to change the course. A sign of how fast things are moving. The last time they taught this class, which was last year, 6 to 12 months ago, these tools were not nearly as widespread or accessible. All right, so those are some short-term measures. Then the conversation turns to, well, in the longer term, 2, 3, 5 years from now, when you have had time to adjust the curriculum, what are we going to do? And here the respondents break into two distinct camps. The first one is the resistance camp. They want to resist the use of these AI tools. So let's see what their rationale is. They want to resist using these tools because they want to stress the importance of learning the fundamentals of programming. Even if AI tools are writing code for you, you have to at least understand enough about programming to judge if that code is correct, to understand what that code is doing. And how would you resist these tools? One big thing to do would be designing AI-proof assignments. What does that usually look like? These kinds of assignments usually have a lot of context, and what that means is they'll usually have some starter code that students then have to modify or add to. So it's not writing code from scratch. And if you just put the questions in, it's not going to have this surrounding context of the starter code. And things like ChatGPT are not going to be so good at generating solutions. I wonder how feasible this actually is given the increasing context window sizes. So I think this is a short-term measure because you could just take the starter code and put it into your prompt and then ask your programming questions. So this might work now when context windows are small, but as they get larger and larger, and with GPT-4, they're already 32 kilobytes and now 128 kilobytes, 128,000 tokens, not kilobytes. I think this measure will work less and less. Another suggestion was to bring back paper exams, have video and image-based assessments. And now let's look at the other camp, the camp that wants to embrace these tools. Why do they want to embrace? One big reason is preparing students for jobs of the future. So obviously all these tools are already getting used very widely in industry and by professional programmers. And if you are to prepare your students for the real world, you have to give them some familiarity with these tools. Another argument is to use tools like Copilot as accelerants, in the sense that if these tools can help students write code faster, you can then give them more challenging, more conceptually challenging assignments and more advanced material that they can cover with the time they've saved coding. These tools would also help instructors because they're really good at explaining code. They can critique code. So they would be like a source of personalized assistance to these students. It can also help instructors. They can use these tools to generate new programming problems or variants of programming problems. And then the question becomes, how do you change what you're teaching or the way you're teaching? One key idea here is to focus more on the reading and critique of code than the writing of code. This idea comes up again and again in the literature on how LLMs affect teaching. You could have more open-ended design assignments, so not just writing a solution to a very well-defined problem. You could even have assignments where students have to work collaboratively with the AI to actually arrive at a proper specification and then judge the quality and correctness of the code given by the AI coding tools. There are still a lot of open research questions. I think the main one is how you actually tailor these tools for teaching. Currently, these tools are designed for professional programmers, so they're designed to give them answers that are as correct as possible as quickly as possible. You could imagine an LLM that is tuned not for simply providing the answer right away, but to serve the function of teaching, to actually maybe give hints or encourage the user to think through the problem if they're stuck. But the biggest question really is, well, what if you had to redesign CS1, CS2 from scratch? The way these two introductory courses have been taught, Intro to Programming and Data Structures and Algorithms, has been mostly the same for the last few decades. And now we see a sea change in the tools available to students and what those tools can do. So this might be a good time to actually rethink these courses from scratch as opposed to thinking about how you could adapt them to these tools. I'll end with that. I hope you enjoyed that. If you like content like this, please like the video, consider subscribing, and I will see you next time. Thank you very much.